What we're going to do now is to spend some time on this special right triangles. There are two of them. One of them is, I'll call it 45, 45, 90-degree triangle, right triangle. And the other one is a 30, 60, 90 right, special right triangle. Now, we're going to begin with the first one. So I'm going to do the 45, 45, 90-degree triangle first. To find a 45, 45, 90, we start out with using a square. Think of a square. And each side of the square has a length of 1, whether it's 1 inch, 1 foot, 1 yard, 1. Now, we do have a right angle at each one of the corners. Now, to make this, we're going to draw the diagonal. Now, that makes us have 2 right triangles. So we don't need 2. We just need 1. Now, if each angle is 40, if that side is 1 and this side is 1, that's an isosceles. And remember, an isosceles triangle, the sides opposite are equal. So that makes this angle 45 and this angle 45. And so we have a 45, 90-degree triangle with the legs being 1. Now what we want to find out is what is the length of the diagonal. Well, in the right triangle, the side opposite the right angle is called the hypotenuse. And before we was dismissed, we learned about Pythagoras' theorem. He said that the square of the hypotenuse is equal to the sum of the squares of the legs. Excuse me. So, I don't know what the hypotenuse is, but the legs are 1 and square it, and 1 and square it. So we have x squared is equal to 1 plus 1. X squared is equal to 2. Now, take the square root of both sides, and x is the square root of 2. So, the hypotenuse, or the side opposite the right angle, is the square root of 2. What that leads us to is the fact of a theorem 9.8. And it goes like this. Theorem 9.8. In a 45, 90-degree triangle, the hypotenuse is the square root of 2 times as long as each leg. So, this machine is backing up on us again. So the hypotenuse is equal to 2 times the length. Now, so what we're going to do now is take a 45 degree triangle, now this isn't exactly a 45, 90 degree triangle, but when I put these as 45, I would like for you to consider that that's what they are. Now, so let's say that the legs are 4. Then what would be the length of the hypotenuse? Using theorem 9.8, which says that the hypotenuse, we're going to abbreviate it HYP, is equal to the leg times the square root of 2. And so the hypotenuse is equal to 4 on the square root of 2. And that's the answer to the hypotenuse. And so that is what we're going to be doing. We're going to be giving the leg and determine the hypotenuse of a 45, 90 degree triangle. And then we're going to invert that. That is, again, this may not look like an isosceles right triangle, but by putting 45 and 45, that is, and let's say the length of the hypotenuse is 4. And we want to determine what is the length of the leg. Again, we use theorem 9.8, which says the hypotenuse, we're going to abbreviate HYP, is equal to the leg times the square root of 2. So 4 is equal to the leg times the square root of 2. Now we've got to use some algebra concepts here. And that is, we want leg by itself, so we're going to divide by the square root of 2. Now, that gives us 4 over the square root of 2. We cannot leave a radical as a denominator. And the expression is rationalize the denominator. To get rid of the radical, we multiply by a radical, with the number being 2. Now, if you put it on bottom, you multiply the top by that. Now, on bottom, the square root of 2 times the square root of 2 is simply 2. But on top, you cannot say a number outside the radical times a number inside the radical. So the answer is 4 on the square root of 2. But the 2 here and the 4 there cancels. So the answer to our problem is 2 on the square root of 2. And that is what we're going to be doing, is be finding given the length of the leg, find the hypotenuse. If you are given the hypotenuse, determine the measure of the legs. Now that's the 45, 90 right triangle. So let's go back to the beginning where we had the 2 special right triangles. and do the 30, 60, 90 degree triangle. Now, since you have 30 and 60 as the two angles, we'll have some lengths of the legs will not be identical. And so we'll need to discuss that aspect. Now, to form a 30, 60 degree, 90 degree triangle, we take an equilateral triangle. Now, hopefully this triangle looks equal all the way around. We know that an equilateral triangle, all the sides are equal. So we're going to say in our demonstration that this side is 2, and this side is 2, and of course the bottom is 2. Each angle, this is 60, and this is 60, and that's 60. Now, the third angle is 60. But what we're going to do again is what we did a while ago, is that we're going to draw the altitude. Now the altitude will form a right angle. Now that makes us have two right triangles, so we're going to do what we did a while ago, is isolate and just have our one right triangle. Now, if this angle is a 90, and this angle is 60, by knowing that the sum of the measures of the angles of a triangle is 180, then this angle is 30. Not only that, if this entire side at the bottom, called the base, is then this measure is half of 2, which is 1. What we need to find out is what is the length of the altitude, and the altitude would be the side opposite the 60 degree angle. So we use Pythagoras' theorem again. Now remember, he said the side opposite to the right angle was the hypotenuse. So this hypotenuse squared is equal to the sum of the measures of the angle besides squared. The hypotenuse equal to the sum of the squares of the legs. So the hypotenuse is 2. Replace it and square it. A is one of the legs, and that is the measure of 1. B is the measure of the other leg, but we don't know that length, so we're going to replace them with x and square. Now square your values. That's 4 is equal to 1 plus x squared. Subtract 1 from both sides to get the x by itself. Then take the square root of both sides. Now x equals square root of 3. And x is the altitude. Now, there's one thing that we've got to discuss about our right triangle before we can move into a theorem. So, let me express that aspect. In a right triangle, where you have a right angle, let's move this more to the middle. That's a right angle. Then this was the 60. This was the 60-degree angle. And this is the 30-degree angle. Now this fella is the hypotenuse. And these two are legs. Okay, now here's the situation. The leg opposite the 30-degree angle is shorter than the leg opposite the 60. So he's the longer of the two legs. The longer leg is opposite the 60-degree angle. And the shorter leg is the side opposite the 30-degree angle. Now what that does is leads us into this. The hypotenuse would be 2. The shorter leg here would be 1. And the longer leg would be the square root of 3. And so that leads us to theorem 9, which reads, in a 30, 60, 90-degree triangle, the hypotenuse is twice as long as the shorter leg. That's the first portion. And the longer leg is the square root of 3 times as long as the shorter leg. And that's the second. So what that presents is this thought. 2 of them. To find the hypotenuse, you would say 2 times the shorter leg. And to find the longer leg, you would say the shorter leg times the square root of 3. So that begins, we're going to work some problems. So, here's the first one. So let's take us a right triangle, a 30, 60, 90 now. A 30, 60, 90. Now, and this, the shorter leg, that's the shorter leg right here, which is the side opposite the 30-degree angle. That's the shorter leg. He's always away from the 30. Let's say that he is 3. Now, I want to know the side opposite the 60-degree angle, which is called the longer leg, abbreviated LL. And I also want to know what the hypotenuse is, abbreviated as HYP. So, we are using theorem 9.9. First, hypotenuse is equal to 2 times shorter leg. So, hypotenuse is equal to 2 times 3. So the hypotenuse is equal to 6. That's the length of the hypotenuse. 6. Now let's find the length of the longer leg. Using theorem 9.9, longer leg. That's abbreviated. Longer leg, LL, is the shorter leg times the square root of 3. So that LL is equal to 3 on, that's red, on the square root of 3. Longer leg is equal to 3 on. That's how you read it, the square root of 3. So over here, it would be 3 on the square root of 3. Now, let's take another approach to this. Since that was given the length of the shorter leg. Let's take it and see how you would do it if I gave you the length of the hypotenuse. Now again, this is the right angle, this is 60, this is 30. Now this is the hypotenuse. And let's say this time I give you the length of the hypotenuse as 4. What would be the length of the side opposite the 30 and the 60-degree angle? Using theorem 9.9, which says the hypotenuse is equal to 2 times the shorter leg. So 4 is the hypotenuse is equal to 2 times the abbreviated shorter leg. SH for shorter, L for leg. Using our knowledge of a little algebra, we eliminate the 2, we divide by 2, and so 4 divided by 2 is 2, and the shorter leg would equal 2. Now he's the side opposite the 30-degree angle. Now that is the length of the shorter leg. Our objective now is to determine the length of the longer leg. Using theorem 9.9, that is the shorter leg times the square root of 3. So the longer leg, abbreviated LL, longer leg, is equal. Now remember, the shorter leg is 2 on the square root of 3. And so that's the answer for the longer leg. And that's all we're doing is determine the length of the sides of a special right triangle given one of the 3 sides. Now that's examples using the length of the shorter leg given and the hypotenuse. Now the third one is given. What would you do if you were given a right triangle, 30, 60, 90? But again, this is the hypotenuse, and this is the longer leg. And that is the length that I'm going to give you, and I'm telling you that is 6. Then what would be this side called the shorter leg? And what would be this side is called the hypotenuse. Again, using theorem 9.9, hypotenuse equals 2 times the shorter leg. Well, here's the problem. I can't start here like I have on the other because this is the hypotenuse, that's the hypotenuse, and this is the shorter leg, and I don't know either one. So we're going to have to begin this problem using the second one, which says the longer leg is equal to the shorter leg, abbreviated, times the square root of 3. Now, the longer leg is 6. So we have the 6 is longer legs, that's given. Remember, I told you over here the length of the longer leg is 6. Now, the shorter leg is found by taking, and we're going to use some algebra skills, and we're going to divide this by the square root of 3, both sides. Well, That means that we have to rationalize the denominator, which means we multiply by the square root of 3, which would give us 3. And of course, you've got a little space here. You've got to put the square root of 3 there. But you cannot multiply the number outside the radical, 6, times the number under the radical, 3. So you write it like this. But we can cancel the 3 and the 6. Not the 3 and the 3, because that 3 is on this. You got 1 under the radical. You can't do that, but you can cancel the numbers outside. And so we have shorter leg is equal to 2 on the square root of 3. So this side is 2 on the square root of 3. But then we got to find the length of the hypotenuse. Well, you would say 2 times the shorter leg. So the hypotenuse is equal to 4 on the square root of 3. And so that is your 3 examples on how to use theorem 9.9, which says the hypotenuse is equal to 2 times the shorter leg, and the longer leg is the shorter leg times the square root of 3. Now, that should help you work the worksheet on these problems.